on from there, we've got the CANdi, which is another one of the new products that we have. It's primarily designed to take digital sensors and put them on the CAN bus. The really cool thing with it is that it's got this feature called float detect. So of the two inputs that it has the ability to detect when that input is high, is low, or is high Z or floating. And what that allows you to do is,
this is the FXS.
First of all, work with basically any sensor that you could want that provides a digital output, PNP, NPN, it doesn't really matter. It can also be used to detect when that sensor is disconnected or severed. So what I've seen teams do is actually take a PNP sensor, have a local pull down next to the sensor, and configure it in a way where if that wire were to be severed, that's an invalid state essentially, because when the sensor is not asserted, it's pulled low. When it is asserted, it's pushed high, and floating is just not valid. So it gives teams the extra reliability to make sure that the sensors that they're using are actually valid, and they're not just treating a erroneous result as being valid. In addition to that, you have features such as short circuit protection. We have a 300 milliamp maximum current output on the CANdi. If you exceed that limit, it'll shut itself off. And that protection is in place such that where even if you were to take the 12 volts shorted directly to the ground, CANdi survives it. It's not really a problem at all. Finally, it's got 24 volt tolerance. So we have many sensors in the FRC market that exist right now that are 12 volts PNP sensors, which means that when it's inserted, it drives 12 volts to the digital output. Some systems are able to tolerate that. A lot of systems are not really able to tolerate that, but the CANdi is designed to take those sensors and just work with them.
So Corey, you mentioned a kind of point that I kind of want to point out a little bit more. So why is it so important? Like, I shouldn't be shorting 12 volt and 5 volts to ground. Everyone knows you shouldn't be doing that, right? Why do we have to build these protections, right?
Well, we all know that FRC is run by high school students, right? So obviously, high school students don't necessarily know that they can't short any signal to any other signal. CANdi is designed with that in mind. You're able to connect whatever input to whatever output, and it'll tolerate it. It's made to tolerate just about anything that you can throw at it. Similarly to like all of our other products, it has reverse polarity protection. You can wire it in backwards, it'll tolerate it just like any of our products made in the last like 4 or 5 years.
So another thing I want to kind of highlight a little bit more on in terms of like the software compatibility. So a lot of teams who are using the CANdi, they're using it specifically to adapt a limit switch to stop their motor whenever they're done intaking a coral, or stop intaking whenever they're done intaking an algae. There are also teams who are also using it to adapt, for example, like an SRX mag encoder or any third-party PWM encoder into the CANdi. Beyond just reducing so you don't have to run like a DIO wire all the way back to your RoboRio, and the features that Corey mentioned over there, there is the complete compatibility with the software ecosystem. So we tightly integrate all of our equipment together to make things as easy to use as you can think of. So when you're using a limit switch wired into the CANdi, sure, you can pull the state directly, but you can also just go to your Kraken X60 or your X44 or your FXS and just say limit switch, CANdi, done. That's it. That's all you gotta do. Limit switch, it'll stop when it's tripped. Done. Same thing for a PWM encoder or a quadrature encoder. You plug in the PWM signal into S1, your V plus or V 5 volt into the corresponding port, your ground. You go to your Kraken X60 or 44. You say, okay, I want fused CANdi, I want remote CANdi, I want sync CANdi, and there's all these different configuration options. But that's all you have to do. There's no decoding. There's no configuration. That's it. You're done. Sure. I just heard someone ask a question. No?
How many sensors can you plug into the CANdi?
So the CANdi as a means to keep the size down, and also as an internal restriction just because of the form factor. It has 2 capable signal inputs. So that gives you 2 PWM inputs, or 2 limit switches, or 1 quadrature, because you have to use 1 for each, the A and the B signal. So that is 2 inputs. Before I head into this next section, does anyone have a question on a particular product or any of that?
So for the CANdi itself, is it 2 inputs plus the CANdi sensor as well? So it's 3 sensors total?
So in the CANdi here on the right-hand side, you have S1 in and S2 in. Those correspond to the signal wire of the sensors. So on here, you wire to your CAN network. So your wire V+, V-, and then to your CAN. On the right-hand side, you have S1 and you have S2. Those could be 2 PWM, 2 limit switches. You can wire 2 sensors to the CANdi, and then the CANdi can interface those out. So you can read 2 sensors simultaneously. The exception to this is quadrature. Quadrature encoders require 2 signal inputs, and those use both of the signal inputs on the output side of the CANdi. And if you notice, and when you go and actually wire the CANdi up, you're very space constrained. And that's kind of the rationale behind. So if you want to add more inputs, you have to increase space. And the idea is that it packages very nicely. For example, it's 1-inch space holes. It works. You can just mount it straight with a 440 screw into West Coast box tube. And most of our products have been kind of designed with that. New products have been designed with that in mind. The FXS has 1-inch and 2-inch spaced holes on the backplating. The CAN range is 1-inch spaced holes as well. And they're all designed for like a 440 screw, 440 bolt that goes straight through into like West Coast box tube, or any of their mechanisms which have standardized on 1-inch spaced holes.
Further, the CANdi has current sensing capabilities, but the CANdi itself is not a dedicated sensor. That's probably what you're. Yeah.
Yeah.
For the CANdi,
Yes.
would that support like a rev color sensor on I2C?
It does not support serial protocols at the moment.